My name is Jeannie, and today I'm going to be going over the concept of triangles in radiation therapy. Before we dive into how similar triangles are used in radiation therapy, let's take a few moments to refresh our memory on what similar triangles are. Two triangles are considered similar when these properties are met. First is that the corresponding angles of the two triangles are the same, or secondly, the corresponding sides are proportional to one another. You're probably wondering, how does this concept apply in the field of radiation therapy? In radiation therapy, similar triangles are used in the process of planning craniospinal treatment fields. This type of plan is a treatment choice for certain brain cancers. The goal of this treatment type is to treat wherever you can find cerebrospinal fluid because some brain cancers are spread via this fluid. For this particular video, we will focus on the spine and how similar triangles are used to plan these treatment fields. When it comes to treating the spine, it is unlikely that the whole length of the spine can be treated all at once. Because of this, the treatment is split into two fields. To prevent overlapping of the fields on the spine and potentially overdosing it, we have to create a gap between the two beams to compensate for that. This is where similar triangles comes in. Now bear with me. Let's go through how to calculate the distance of this gap using the geometry of the beams. For triangle A and small a, they both have a 90-degree angle. Next, the two corners that touch on these two triangles make the same angle due to the intersecting lines. Knowing 2 out of the 3 angles, you can determine the last one because all triangles have an angle sum of 180 degrees. After all of this, you know you have two triangles with the same angles, therefore concluding that these are both similar triangles. Now that we understand how to get the angles, let's go into how we determine the length of the gap. Looking at this figure, you can see the sides of the two triangles labeled. The distance from the radiation source straight down to the skin surface is the SSD, the source to skin distance. The SSD in triangle A is proportional to the side labeled D in the smaller triangle. The base of the bigger triangle, labeled B, is proportional to the base of the little triangle, which is half the distance of the gap that we are calculating for. For all the math people in here, this simply becomes an equation that looks like this. Once you finish this calculation, you do this again for field number 2, and ta-da! You have calculated the gap between the beams using the concept of similar triangles. At the end of the day, we have to remember that delivering radiation has to be given precisely and accurately because the consequences can be very high. If the calculations are not done correctly during treatment planning, there's a risk of overtreating or even undertreating the spinal cord, which can lead to paralysis or myelitis. Thank you for listening, and I hope this helps you understand how significant triangles can be in radiation therapy.